Hi everyone, this is Mr. Richmond, and for this video we're going to be looking at your Phet plate boundaries activity. So before we start getting into the boundaries and the types of land formations that those boundaries will form, I think it's important for us to look at a couple of these physical properties that can be observed on this first tab. The most important of which is the composition, or how much iron or silica either the continental or oceanic crust contains. So I'm going to be changing the amount of iron or silica for this slab of crust here, and I want you to notice what happens. So if I'm increasing the amount of iron, you can see this crust start to sink below compared to the continental crust. You should be able to come to the conclusion based off of your prior knowledge of what density is. If something is sinking below compared to another material or object, this would suggest that the oceanic crust is more dense than the continental crust. Why? Because it contains more iron, which we know has a greater mass and density compared to the element silicone or silica. So let's increase the amount of silica and see what happens. It looks like the continental crust is then rising, becoming less dense. So that's an important concept for you to understand moving forward with this activity, is that oceanic crust contains more iron, and as a result, it is more dense compared to the continental crust. So let's click on our plate motion tab, and let's start off with, let's say, continental and continental crust. And you're going to be observing these two types of joysticks, and you can move the types of crust either away from one another, towards one another, or sliding past one another. So let's observe what happens when we converge them together. So because continental crusts have the same density, and because these plate boundaries are moving towards one another, we call that a convergent boundary. And I want you to observe the type of land formation that you think this would really kind of resemble here. And to me, that looks like the formation of mountains. And that's how mountains are created, is through convergent continental to continental boundaries. So that's an important concept for you to understand. And let's start off with another one. So I'll do continental and continental again, because remember, we can converge them together. We can also diverge them. So we call this a divergent boundary, or pulling them apart from one another. And this is pretty typical what happens in the mid-oceanic ridges. So we have two continental crusts pulling away from one another, and as a result, you have molten magma and lava coming up from inside the Earth's interior, cooling, hardening, and creating new land. So when we have continental crust, or oceanic crust even, pulling away from one another, we call that a divergent boundary, and it forms new land. So let's try this again with continental. I think we have one more trial. And let's observe what happens when they slide past one another. So this is conclusive. I know this simulation doesn't do a great job of allowing you to identify what kind of land formation is caused here, but this is what is pretty common, especially with the western part of our state, typically in California and Mexico. We have two boundaries sliding past one another, and every so often tension will build up and then eventually release, which we know as an earthquake. So let's reset that again, and let's do one or two more here. Let's have a continental and oceanic crust. And remember, earlier from this video I discussed that oceanic crust is more dense than continental crust. So let's look what happens if we were to converge them. Convergent boundary, oceanic and continental coming together, and as a result, trenches can be formed because you see this oceanic crust being subducted. So that's, again, another important term for you to know, the term subduction. And because we have a greater density crust going in towards a less dense continental crust, we see this volcanic activity start to happen on the Earth's surface, as well as a trench formed perhaps in our ocean. So those are some land formations that an oceanic continental convergent boundary can form, volcanoes as well as trenches. So that was, I believe, old oceanic crust. And let's look at if there's any difference between that and young oceanic crust. It's probably going to be pretty similar, I would guess. So again, this is oceanic continental convergent boundary. Similar idea, we have that process of subduction going on. The oceanic crust subducting underneath the less dense continental crust, forming trenches as well as volcanoes. Last point I want to bring up to you, let's do old oceanic and old oceanic. If we create another divergent boundary pulling away from one another, the newer land that's going to be formed here is along the mid-oceanic ridge. So you can always find newer land being formed right where those two slabs are being pulled apart, right where those two continental or oceanic plates are being pulled apart from one another. The further away that you get from this mid-oceanic ridge, the older that land is going to be. So I hope this video helps your understanding with the types of boundaries and the land formations that are created as a result. Have fun with the simulation, and good luck on your assignment. As always, contact me with any questions. Take care.